Chapter 3, that's products and factors. So 3.1 is all about factors and multiples. Okay, these are things you've dealt with in grade 9 and any lower grade, but we're going to talk about them a little bit more. Now, we have to know how to do this thing called prime factorization. So remember what a prime number is. Okay, so a prime number is simply a number that has its only factors are itself and 1. So like 6 is not a prime number, so like 3. Prime number of 3 is just positive or negative 1 and positive negative 3. So remember, these are the factors. So factors are things that multiply to a number. So 3 times 1 equals 3, negative 3 times negative 1 equals 3, and that's about it. That's the only numbers that you can multiply to get to 3. Whereas 6, its factors are going to be 2, 1, 3, and 6, right? 2 times 3 equals 6. 6 times 1 equals 6, so on and so forth. You could also use the negative value, so negative 2 times negative 3 equals 6. Negative 6 times negative 1 equals 6, so on and so forth. So that's why we usually always put positive negatives here, as you can see. So these are all the factors of 6. Now, what prime factorization is we put numbers into just its primes, okay? And what we're going to use is called the tree method. Now, the tree method is pretty easy. What you do is you just start dividing this number, so 3,300, and we divide it into its prime factors. So the first thing I'm going to do is divide this by 2. Okay, and I'm going to pull out a calculator here. So 3,300 divided by 2 equals 1,650. And then I'm going to now, this is a prime number, so I can't do anything to that, but I can now divide this. It ends in 0, so I'm actually going to divide it by 10. Okay, so I'm going to divide this number by 10, and I'm going to get 165. Now recognize 10 I can divide by 5, so I'm going to divide this by 5. And when you do 10 dividing 5, you get 2. Okay, and now 5 here is a prime number, 2 here is a prime number, and so is up here. But now I can keep simplifying this. So it ends in a 5, so I'm going to divide it by 5. So let's go to my calculator. 165 divided by 5 gives me 33. 33 you can divide by 11, and that gives me 3. And I can no longer divide these numbers. These are all prime numbers, 2, 5, 2, 11, and 3. Now I've prime factorized this thing. Now recognize, this means that if I take 2, multiply 5, multiply 11, multiply 3, if we do that in our calculator, let's do that. So 2 times 2 times 5 times 11 times 3, this value here is actually going to equal 3,300. Oh, I missed a 5. I missed a 5. There's a 5 right there. So I had one 5, I missed the other. So we got to multiply 5 in here. And this is how you can check your answer. So you can see how useful this is to check your answer. So it's actually 2 times 2 times 5 times 11 times 3 times 5. 2 times 2 times 5 times 11 times 3 times 5. There you go. And that gives you 3,300. Okay. Now this is prime factorized, okay? So I can represent this number in terms of all of its factors multiplying each other. Now recognize, remember, like if you have 2 times 2, that simply equals 2 squared. Okay, if I had 2 times 2 times 2, well that equals 2 cubed, because there's 3 of them multiplying. These exponents tell you what to multiply these numbers and how many to. So here I'm going to combine this and write it as 2 squared. I have 5 and 5, so that's going to be times 5 squared. And then I only have 1 11 and 1 3. So I'm going to represent my prime factorized number as that. So I could even plug that in. 2 squared, right? I have a square button here. Times 5 squared times 11 times 3, and it still equals 3,300. So there I have prime factor as my values. Okay, so the tree method is really useful, as you can see. Now moving ahead, we are going to notice that we can find things called the greatest common factors, and we can use prime factorization in order to do this. Okay, so what is a greatest common factor? So this is also known as a GCF. Okay, so finding the greatest common factor is really useful. And we can use prime factorization. Okay, so determine the greatest common factor of 126 and 144. So how do we do this? Well, I'm going to do the tree method on 126, and I'm going to find 144. Okay, now here we divide this thing by 2, and we're going to break it into its prime factorized form. So 126 divided by 2 gives us 63. 63 I can divide by 3, I'm pretty sure. Yep, so this is divisible by 3, and that's 21. I can divide 21 by 3, and that will give me 7. And now each number here is prime factorized, so I can leave it. So 126 equals 2 times 3 times 3 times 7. Now I'm going to prime factorize 144. So I can divide 144 by 12, and that gives me 12. I can divide both these numbers by 2, okay, and that gives me 6. And then I can divide 6 by 3, 6 by 3. And now I can represent 144 as, well, there's 1, 2, 3, 4 2's, so 2 times 2 times 2 times 2 times 3 times 3. And there we have our value. Let's maybe check if I got that right. So 2 times 2 times 2 times 2 times 3 times 3. And there's 144. Great. Now, remember, we're trying to find the greatest common factor. So what is the greatest common factor? The greatest common factor is the biggest number that both of these values are divisible by. So biggest number that you can divide two numbers by. Okay, so how do we use our prime factorization in order to figure this out? Well, you have to find the prime factors that they have in common. So here, both of these have one single 2. They also have 2 3's in common, and that's all they have in common. So their greatest common factor is going to equal 2 times 3 times 3. And that's going to give us 2 times 3 is 6, times 3 is 18. Let's just check that. So 2 times 3 times 3, that gives me 18. So their greatest common factor will be 18. So this is the biggest number that you can divide both 144 and 126 by. So that's your greatest common factor, and that's how to use prime factorization. So I can do 126 dividing 18, and that's going to give us, let's see here, oops, 126 divided 18, that gives us 7. Okay, and then you can do 144 dividing 18. Let's see what that gives you. 144 divided by 18 gives you 8. So you can see that this is a very large number that we can divide by. Okay, so that's the greatest common factor. Okay, we use prime factorization in order to figure that out. Now something you can also do is find something called the lowest common multiple. So remember what multiples are. So if I count up by 6, 6, 12, 18, 24, these are all the multiples of 6. right? Because this equals 6 times 1, this equals 6 times 2, this equals 6 times 3. So to find the greatest common multiple, or sorry, the lowest common multiple, you're trying to find at what point do these numbers converge, okay? And again, you can use your prime factorization. So here, let's prime factorize. So we're going to prime factorize each number, so divide this by 2, that gives you 14. Divide that by 2, that gives you 7. So 28 equals 2 times 2 times 7. 4 here, we're going to divide 42 here, we're going to divide by 2, and that gives us 21. Divide 3, and that gives you 7. Okay, so 21 divided by 3 gives you 7, so 42 equals 2 times 3 times 7. 63, that's divisible by 3, and that gives you, let's check here. Oh, that's the wrong. So 63 divided by 3, that gives you 21. And then we can divide 21 by 3, and that gives you 7. So 21 divided by 3 gives you 7. So here, 63 equals 3 times 3 times 7. Okay, now how do we find the lowest common multiple here? Well, what you're going to do is you're going to try and take the lowest amount of numbers, okay, and combine them. So what do they all have in common? So they all have in common a 7. They all have in common a single 2. Actually, they don't have in common a 2. So far they only have a 7 in common. So their lowest common multiple will be 7 multiply, and we got to make sure we have every single value accounted for. So this has the most amount of 3's here. So we will take into account the 3's. So this will be times 3 times 3. Where's the most amount of 2's found? The biggest amount of 2's found is here. So we will do times 2 times 2. And that should be our lowest common multiple. So 7 times 3 times 3 times 2 times 2. So 7 times 3 times 3 times 2 times 2. So 252. We can check that. Let's divide by 28. Okay, that's good. 252 divided by 42. And 252 divided by 63 is 4. Okay, so there is our lowest common multiple. Okay, so hopefully we can kind of understand that. I would definitely suggest practicing a few problems where you have to find the lowest common multiple and use your prime factorization. So again, what did we do here? We prime factorized everything, we wrote them out, and now your lowest common multiple has to have the largest amount of each number multiplying themselves. So 7 only shows up once, so 7 will go once. 3 shows up twice in 63. It only shows up once here, but we want the most amount. So it'll be 3 times 3. And then 2, even though it shows up here, it shows up twice in 28. So we're going to multiply it twice here. And then the multiplication of all those gives you your lowest common multiple. Okay? So we can use these to our advantage in different types of word problems. Okay? And these word problems can be a little tricky, but with some practice, it can become a little even interesting and kind of cool to find these questions. So, what is the side length of the smallest square that could be tiled with rectangles that measure 8 by 36? Assume the rectangles cannot be cut. Sketch the square and rectangles. Okay, so what is this question asking? And let's kind of try and imagine it. What is the side length of the smallest square that could be tiled with rectangles that measure? Okay, so here we have some rectangle, and what we're trying to do is we're getting tiles that are 8 inches by 36. Okay, Okay, so this side could be 8 inches, and this side's 36. What we're doing is we are trying to tile a square. Okay, so I should have drawn this shape a little bit more square-like. Okay, and remember, a square has equal sides. So it wants to know how many rectangular tiles does it fit in order to make this square. Okay, so we don't know this. This could keep going on, and this could be smaller and smaller. Now recognize this can only go up by increments of 36 based on the size of our tiles. This can only go up by increments of 8. Okay, and we want to make this square. Now what we're actually asking here is, when can we get the same side length over here as the same side length here using 36 lengthwise on the top and 8 lengthwise on the side? Okay, so here, even though it's asking for the smallest amount, we're actually trying to find the lowest common multiple. Okay, so we're trying to find, when does 36, if we count up by 36s, when is that going to equal the same by counting up by 8s? So we got to find the lowest common multiple here. So here again, to find the lowest common multiple, we can use prime factorization. So divide by 2 here, 36 divided by 2, that gives me 18, dividing 2, that gives me 9, 3, and 3. So 36 equals 2 times 2 times 3 times 3. 8 over here will be dividing 2, and that gives me 4, dividing 2, and that gives me 2. So 8 equals 2 times 2 times 2. Okay, and now remember, to find the lowest common multiple, what are we doing here? Well, we're trying to get every single number in here that has the largest amount. So even though this has 2 2's, this has 3 of them. So I'm going to use 3 2's. So 2 times 2 times 2. And now 3 pops up in one of these, which is over here, and it multiplies twice. So times 3 times 3. And then we can plug that into our calculator here. So 2 times 2 times 2 times 3 times 3 gives you 72 inches. Okay, so that means, sorry about that. What does this mean? Well, we can now imagine this triangle a lot, or this rectangle a lot better. Okay, so realistically, this square only needs 2 36-inch rows, okay, because together this equals 72. Over here, what is 72 dividing 8? Okay, 72 divided by 8, well, that gives me 9. Okay, so that means we're going to need 9 rows here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, each little thing here is 8 inches. If you add up 8 9 times, that will be 72 inches. So now you can see we have the side lengths that are the same, and that's what the lowest common multiple has helped us find. Okay, so it looks like in total, how many tiles will we need? Well, we'll need 9 times 2, so we'll need 18 tiles total. Okay, but this will be the smallest side length that we can make in order to make a square. Okay, now let's look at B. What is the side length of the smallest square that could be tiled with rectangles that measure 8 by 36? So this question is totally different. This is saying if you're given an 8-inch by 36-inch thing to tile, and we could only use little square tiles to tile this thing, what's the measurement of this tile? So this side length here has to be equal to this side length. Well, that is going to be your greatest common factor. Okay, so how do we find our greatest common factor? we use our prime factorization. So we've already prime factorized 36, right? We did it up here with the tree method. So 36, let's just erase this. 36 equals 2 times 2 times 3 times 3, just like we figured out. 8 equals 2 times 2 times 2. And now we want to know the greatest common factor. So the greatest common factor is a little bit different to find. Remember, you just find what they have in common, okay? So here, they have 2 2's in common, and that's it, okay? So here, the greatest common factor will be 2 times 2, which equals 4. So it looks like in order to tile this thing, we'll need little 4 by 4 inch cubes, okay? So this will be 4 inch cubes. So we'll use, for tiling, 4 inch by 4 inch cubes. And you can place those alongside and it'll equal perfectly up to 36 and 8. Okay, so this stuff can be a little confusing. The biggest thing is make sure you understand how to use prime factorization. Make sure you understand how to use prime factorization to find greatest common factor and then lowest common multiple. The word problems, if you want to get a really high grade in Math 10C, the word problems you definitely want to understand. They're good to understand as well because they also help just clarify what lowest common multiple means and what greatest common factor means. Okay. Other than that, make sure you now go and check your understanding with AFL 3.1.